Okay, so let's try an example here of writing a quadratic function in the form listed up above. So let's look at the quadratic function f of x equals x squared plus 5x. Alright, the first thing we would need to do is make sure there's a 1 in front of the x squared, so factor anything out. And there is a 1 in front of the x squared, so that's good. So typically if there were a constant out here like a plus 3, I would have to separate the x's from the 3, but there is no plus 3, so I don't need to separate anything. So at this point I'm simply going to create an artificial set of parentheses just to sort of isolate my x's, and then in my next step I'm going to complete the square inside the parentheses. And I have to figure out what to add here, so I take the 5 times a half and square it. So that's 5 halves squared, which gives you 25 fourths. So I'm going to add 25 fourths. Now in doing this I've unbalanced this equation, so I need to somehow balance this positive 25 fourths out. Now typically we like to add it to the left side because I added it to the right side. But since the left side's a function, I can't mess with it. So the other way to fix it is to subtract the 25 fourths back off of the same side, but outside of the parentheses. And so we end up with, we have to factor this trinomial. It's going to be a perfect square. It's going to be x, and then you take half of the positive 5 and put it here. Well, half of positive 5 is 5 halves. And then you just carry down your minus 25 fourths that's out here. So now this is in the form that we wanted in, and the vertex in this case would be negative 5 halves, comma, negative 25 fourths. And you can check that. Alright, so you can get fractions in these too, so know how to handle those. Alright, in this example we need to separate the negative 2 from the x squared. So I'm going to factor it out of the x terms because I also need to isolate the x terms from everything. So I get x squared, and when I factor negative 2 out of a positive 12, I get a negative 6x, and I'll just carry down my plus 1. I'm always separating my x's from my constant term and factoring out the number in front of x squared. Then inside the parentheses I need to complete the square on the x's. So to add something in here I would take 1/2 times the negative 6, square it, so this is negative 3 squared, which is 9, so I'll add a 9 here, and I've added a 9 inside the parentheses, which really amounts to subtracting negative 2 times 9, so it's subtracting 18 from the right side. And to balance it now I have to do something on the right side, so to balance subtracting an 18 I need to now add an 18 to balance it. So the second step and the third step are literally the same thing, just written in different forms. Now I can factor what's inside the parentheses, which is a perfect square. I have x, and then half of the negative 6 is negative 3. And then 1 plus 18 on the outside is positive 19. So now we've got our function into the right form, and the vertex would be the order pair 3, 19. Okay, so here we need to, there's already a 1 in front of the x squared, so I'm going to separate my x terms by putting parentheses around them. And then I'm going to complete the square inside the parentheses. So I have to figure out what to add, so I have to take the coefficient of x here, which is a negative 1. So I'm going to take negative 1 times a half and square it. Negative 1 times a half is negative 1/2, squared is positive 1/4. So I need to add a 1/4. And there's nothing out here to distribute to the 1/4, so I literally just added 1/4. So now I will subtract the 1/4 to keep the right side balanced. And now I can factor the left side. So I've got something squared, and it's x. And I take half of this negative 1 that's in front of the x again. Half of negative 1 is negative half. And negative 1 minus a fourth is negative 5 fourths. So the vertex in this case would be positive 1/2, comma, negative 5 fourths.